My name's Mark Amor-Segan. I'm Principal Research Engineer for the Energy Innovation Centre here at WMG. WMG is one of the UK's leading centres for working together with industry to take ideas from an academic setting into an industrial context. At the Energy Centre here, our focus is on energy storage research. We have some unique facilities in the UK which allow us to go from experimental chemistry development through to cell manufacturing, through to full battery pack manufacturing and deployment. Here at the Energy Innovation Centre, we work with a range of automotive manufacturers, from passenger cars through to extreme motorsports and supercar developers, through to some of the motorsport applications such as Formula E and Formula One. The future of electric cars depends upon having an energy storage system which will allow it to effectively replace the internal combustion engine. Current technologies such as lithium-ion batteries are a technology that's migrated out of other industries such as your mobile phone and laptop batteries and so on. And we're now asking the technology to do something that it wasn't asked to do previously. So these new energy storage systems have to have a highly durable and long lifespan, so 10, 20, 15 years. So as a result, we're now having to look at using this technology in a different way. In terms of what limits the use of battery systems for a vehicle application in automotive at the moment, there's really three main areas. One is performance, the second is cost, and the third is safety. So the research centre here at WMG, those are the three main focuses of our research and the work that we do with the automotive companies. So all the time we're trying to improve the performance, such as energy density, power densities. This is all about range and acceleration. But at the same time, in order for the automotive world to adopt these new technologies, they need to be developed so that they can be produced at the right cost. So cost is paramount in the automotive world. So we're looking at technologies and techniques which will allow us to deliver the performance that we need, but at the cost that's acceptable to automotive. In order to understand the behaviour of the different energy storage systems and different chemistries, we test them in a protected thermal chamber known as a UKAR hazard level 6 thermal chamber. So this allows us to test the energy storage systems and the batteries to their absolute limits, but keep everybody safe. So some of the newer chemistries, we may not know where those performance limits are. So to ensure that we keep everybody safe, we test them in these UKAR hazard level 6 chambers. The chambers that we've adopted in the Energy Centre here are E-spec UKAR level 6 chambers. The reason that we've chosen the E-spec chambers is not only their performance, their safety features, but the fact that in terms of the available test space for a given footprint or floor area that they occupy, they are the best in market at the moment. Our work is now expanding into all the other industry sectors such as aerospace, marine, rail, static energy storage, and even wearable electronics.
Working at WMG with all this latest equipment allows us to accelerate the speed of the research and development of the electrification, which is going to be required all over the world in the next few years. We have a unique facility and capability which allows us to go from the powder to power. What it means is we start our research from the very fundamental level. We will start by looking into the materials which go into the battery as a cathode, anode, separator, and electrolyte. We have a quite wide range of equipment which allows us to assemble all the components into the battery as in cylindrical format, pouch format, and potentially in other formats. And after that, we have a well-equipped battery testing laboratory which allows us to look at the behavior of the batteries in almost every single aspect. That includes mechanical, thermal, electrical, and also the safety aspect of the things. So there are three key attributes we have to take into consideration when we come to the design and the development of the energy storage system by using batteries. So these are the performance, cost, and also safety and reliability. So all our thermal test chambers are rated at the UKAR hazard level 6, which means we are capable of dealing with a hazard or the event, for example, the thermal runaway from the battery. There are several reasons that we have selected thermal test chambers for them to be used in order to carry out our battery experiment. First of all, it's very important to be able to produce the repeatable and reliable results. By using thermal test chamber, we can ensure all our experiment is carried out in a consistent manner and also in a temperature-controlled environment. Secondly, the E-spec thermal test chamber gives us the capability to operate all those potentially dangerous battery experiments in the protective environment to ensure the health safety on campus. In addition, all our thermal test chambers are specifically designed in accordance to the UK Hazard Level 6 rating. We can look at our battery's behavior and performance at the room temperature, but also in some very harsh environment, which involves a very high temperature or very low temperature. And also, we can store our batteries in the site temperatures during a very long period of time, and then we can revisit them to look at how their performance change and degrade over the period of time. The battery testing is crucial in order to help our industrial collaborator to select the most suitable battery for the right application.